An alpha particle and a proton are released from the center of the cyclotron and made to accelerate. 1. Can both be accelerated at the same cyclotron frequency? Give reason. 2. When they are accelerated in turn, which of the two will have higher velocity at the exit slit of the dees? So we have a basic diagram, okay, for cyclotron. Now we are going to use the expression for cyclotron frequency in this problem. So I'm writing, okay, cyclotron frequency Fc equals EB by twice pi m. So we are going to use this relation, okay, in this problem. So let us call it equation 1, and small e, okay, this is charge, and B, this represent magnitude, okay. So this represent magnitude of magnetic field, and M represent mass of charge. Now we have alpha particle and proton. So for proton, charge equals plus E, okay, proton is positively charged, and let us denote mass of proton by the symbol MP. For alpha particle, okay, alpha particle, so we know alpha particle is helium nuclei. So charge of alpha particle is plus twice E, and let us denote the mass of alpha particle by the symbol m alpha, and we know mass of alpha particle is 4 times the mass of proton. So we are going to use, okay, these concept and symbol, okay, for this problem. Now case 1, okay, can both be accelerated at the same cyclotron frequency? Give reason. So we are going to express equation 1 for proton and alpha particle. So I'm writing in this way, okay, cyclotron frequency for proton, okay, this equals, so I'm writing in this way, okay, using 1. Clear? So charge on proton is plus E, and magnetic field, okay, is B divided by twice pi, and mass of proton is MP. So let's write in this way. Cyclotron frequency for proton equals E B by twice pi MP. Let us call it equation 2. So we have this, okay. Now case 2, okay, for alpha particle. So we can write in this way. Cyclotron frequency for alpha particle equals, we are using equation 1, okay, charge on alpha particle is plus twice E. So we have magnetic field B divided by twice pi m alpha, okay. So we have 2EB, okay, divided by twice pi, and we know m alpha, okay, mass of alpha particle is 4 times the mass of proton. So we have this. Therefore cyclotron frequency for alpha particle equals So we have, let us simplify this also, okay? So we get this 1 by 2, okay? And we have EB by twice pi MP. So we have this, okay? And we know this ratio is frequency of proton. Therefore, we can write cyclotron frequency of alpha particle is half of cyclotron frequency of proton. Or we can write cyclotron frequency of proton is twice the cyclotron frequency of alpha particle. Okay? So we have these relation. So from 1, okay, can both be accelerated at the same cyclotron frequency? So what we find, okay? So we find cyclotron frequency for proton is not equal to cyclotron frequency for alpha particle. So they cannot be accelerated at the same cyclotron frequency. So we have, okay, this conclusion. Proton and alpha particle, okay, cannot be accelerated at the same cyclotron frequency. So we have this case 2. The velocity of the charge or charges will be maximum, okay, when they move near the surface of the dees. So I'm writing over here. So that is when charge particle moves near the surface of the dees, then it will have maximum velocity. So I'm writing over here, the velocity of charge or charges will be maximum near the surface of the dees. And since the charge or charges are moving in the presence of magnetic field, so they experience magnetic force, and this is the expression for magnetic force in magnitude. And since the charge or charges are moving in circular path, okay, therefore the centripetal force equals mv square by r, where r is the radius of the largest circular path, and this r, okay, small r, is approximately or nearly equal to the radius of the dees. Okay, so we have this, and we have, okay, centripetal force equals to magnetic force. Okay, so we have this. So for largest or maximum velocity, we can write in this way, okay, m v max square by r equals, okay, magnetic force is this, E v max b, and we have theta, okay, equals 90 degree. So for magnetic force, okay, to be maximum, okay, we are taking sine theta maximum. That is when angle between velocity and magnetic field is 90, then the magnetic force is maximum. Okay, so we are taking this condition. So we have this. Okay. Now this cancels out. Okay. Therefore, we can write m Vmax by R equals EB. So we have this, or we can write Vmax equals EB R by M. So we are going to use this expression, okay? So we are going to use this expression for proton and alpha particle. So maximum velocity for proton, okay? So this is for proton. This equals charge on proton, and we have magnetic field, okay? And R is the radius of largest circular path, okay? Or approximately the radius of the dees. So we have this divided by mass of proton. Okay, so we have this. And for alpha particle, okay, for alpha particle, so we can write maximum value for alpha particle equals charge on alpha particle is twice E, okay, plus twice E, B R divided by mass of alpha particle. And we can rewrite this equation in this way: twice E BR by mass of alpha particle is 4 times the mass of proton. So we have this. Therefore, we have maximum velocity of alpha particle equals EB R by twice MP. So we have this. Okay. So let us call it equation 4. This is equation 4, okay? This is equation 4. Now, from 3 and 4, so we have this. So we are using 3 and 4. So we can write in this way. And we know this is maximum velocity of proton. Therefore, maximum velocity of alpha particle is half of maximum velocity of proton. Or we can write maximum velocity of proton equals 2 times the maximum velocity of alpha particle. So we have this relation, okay? So let us see the question. When they are accelerated in turn, which of the two will have higher velocity at the exit slit of the D or D's, okay? Which of the two will have higher velocity? So what we find? We find velocity of proton is greater, okay, then velocity of alpha particle, okay, at the exit